Hello everyone, and thank you for tuning in to my presentation. My name is Amanda Klingler, and today I'll be talking to you about work I did as part of my REU program experience at UC Berkeley, which investigated how environmental context influences the consequences of exploratory personality. In recent years, it's become increasingly clear that it's important to understand the causes and consequences of individual differences in behavior. We measure these differences using behavioral axes, and one axis that I was particularly interested in is exploratory behavior, or the propensity for an individual to actively explore and engage with its environment. As you can see by the animation I just played, being highly exploratory in stable environments is beneficial in terms of resource acquisition. However, we know that in nature there are trade-offs between this highly exploratory behavior and environmental factors such as temperature, weather, and predation risk. However, few studies on personality examine this trade-off. Here, we wanted to understand how the environment, and specifically how temperature, influences the consequences of different exploratory personality phenotypes. We decided to use Habronattus pugillis Griswold as a model organism to answer this question, as it's a desert-dwelling ectotherm that regularly experiences a range of temperatures. They would also likely receive a benefit from being exploratory due to their highly visual and active hunting style. To understand the relationship between exploratory behavior and fitness in the environment, we used a repeated measures design where each individual completed 2 assessments of exploratory behavior to calculate repeatability, followed by an assessment of prey capture proficiency at the 3 ecologically relevant temperatures you see here. This design allowed us to ask questions about both variation in exploratory behavior and prey capture proficiency. And because each individual completed all the trials, it enabled us to examine the relationship between exploratory personality and prey capture proficiency across this thermal range. To assess exploratory behavior, we placed individuals in the arena you see here, and they had 300 seconds from the trial start to emerge from their container and 600 seconds after they had emerged to explore the arena. We conducted these trials at 25 degrees Celsius. We recorded these trials and assessed each individual on a number of factors we deemed relevant to quantifying their exploration. We assessed prey capture proficiency in an arena like the one pictured here inside an incubator set to the appropriate trial temperature. We placed the spider in the arena, released the fly, and then gave each individual 300 seconds from the release to capture the fly. We also recorded these trials and scored individuals on a number of factors we deemed relevant to assessing prey capture proficiency. For the purposes of this talk, I'll be focusing on the time it took individuals to capture their prey. When looking at the data collected from the exploratory personality trials, we found that PC1, or principal component 1 from our principal components analysis, explains 63% of the variance with a repeatability of 0.59. These results make us confident that the assay we use is an appropriate and repeatable measure of exploratory behavior in this species. Next, focusing on the time individuals took to capture their prey in the prey capture trials, we see here in seconds on the y-axis the time individuals took to capture their prey across temperature here on the x-axis. And we see that as temperature increases, individuals take significantly less time to capture their prey. Finally, when we investigate the relationship between exploratory personality, represented by PC1 on the x-axis, and prey capture time in seconds, again on the y-axis, we do find an interaction of exploratory personality and temperature, but only at 15 degrees Celsius. Here we see that more highly exploratory individuals take longer to capture their prey than their less exploratory counterparts at 15 degrees Celsius, but show no differences in time to capture their prey at the 2 other temperatures. So in conclusion, we find first that individuals do in fact exhibit repeatable differences in exploratory behavior. Second, we find that regardless of exploratory personality, prey capture time is significantly affected by temperature. Given that these are ectothermic animals, it's not surprising that their ability to perform a physical task like capturing their prey would be affected by external temperature. And finally, and somewhat counterintuitively, we find that more highly exploratory individuals take longer to capture their prey at the lower end of their thermal range, 15 degrees Celsius, but not at the other temperatures we tested. This unexpected result opens up exciting potential future projects that could investigate potential trade-offs between metabolic processes that help with thermal regulation and personality that may lead to this observation. With that, I would like to thank my REU site at UC Berkeley and my institutions. Thank you for listening.